Hello, and welcome to the second out of 9 speedruns today. There's a lot to go through. Let's go. And in this case, in this speedrun, we're going to be covering rational functions. So what is a rational function? A rational function is any function that can be expressed as the quotient of two other functions, of two polynomial functions, actually. In case you don't know, what is a polynomial function? A polynomial function is simply a function that can be expressed as like a bunch of powers of x added together. So something like this would be a polynomial function. Um, so yeah, this is a rational function. And the graph of a rational function usually, but not always, looks something like this. Well, actually, no, it's only, well, let's not get too complicated. But it looks something like this, and that's because you can see there's like gaps here along some of the axes, and the reason why there are gaps is because for some values of the function, it's impossible to get the y value. So for example, if our function is just y equals 1 over x, the classic rational function, the thing is, okay, the graph looks like this, and that's because there's clearly no value for the function here when x equals 0, since we can't divide by 0. You can't divide by 0, and similarly, when y equals 0, so 0, you also can't divide by 0, since 0 is equal to 1 over x, so um, you have to solve for the equation x is equal to 1 over 0, and the answer just simply doesn't exist. So most of these two lines that for values that don't exist in the function are called asymptotes. And what the function normally does is the actual line of the function will tend towards the asymptote, and if you keep it going close to infinity, it will get very, very close, but it will never actually reach that number. So common problems for rational functions are to find the domain and range and to find the asymptotes, and that's what we're going to be looking at in this very short speedrun. So again, skipping, we'll do the odd questions. So we need to find the domain. Oh, it's gone. We need to find the domain and range of the following functions and state the equations of any asymptotes. So our first function is y is equal to 3 over 4 minus 2x. And, well, first let's find the domain and range. To find the domain, this function should be okay for an infinite domain, so as long as x is part of the real number set, but there will be asymptotes, and so we need to specify what those asymptotes are and when x won't equal. So to find the domain asymptotes, or to find more or less asymptotes in the x value, we need to set y to 0 and see what values will give an error for x. Or actually, we need to rearrange this more like into 4 minus 2x is equal to 3 over y. When y is 0, this, wait. Sorry, no, that's not what I meant. Oops. Let's go back on that. No, to find the vertical asymptotes, which are the x asymptotes, because they're just values of x, we need to find all the cases when this denominator is equal to 0. And in this case, we only have one case. The denominator will equal 0 when x is equal to 2. So we have to simply say x is not equal to 2 in the domain. For the range, however, we need to find the values that are impossible to solve when y, well, for y. And we'll do that by rearranging this function into the form 4 minus 2x is equal to 3 over y. When y is 0, this function will also, be impossible to solve, and and y is 0 when, well, y is 0. So as again, the range is when y is part of the real numbers and as long as y is not equal to 0. Okay, for the next function, we have y is equal to x over 2 minus 4x. So, yeah, so the domain, we forgot to find the asymptotes for the previous one, but we'll just find them for this one. So this also looks like an infinite function, so it will be when x is equal to any real number, except for whenever this denominator is 0, and this denominator is 0 when x is equal to 1/2. So x just simply cannot be equal to 1/2. Are there any other cases? No, I don't think so. And so to find asymptotes in the range of this function, well, we need to figure out, okay, so for what y values will it be impossible to find a value for x? And we will do that by solving the function for x. Sorry, mental block. We will do that by solving the function for x. So we need to rearrange this to solve for x. So we have, what is this? We have y times 2 minus 4x is equal to x, I believe. Yep. So 2y minus 4xy is equal to x. So if we bring this over to the other side, we have 2y minus x times 4y. Oh, sorry, no. 2y is equal to x plus 4xy. And so therefore, 2y is equal to x times 1 plus 4y. So we have x is equal to 2y over 1 plus 4y. And so now we need to find the values for which this denominator is 0 to get the range. And this denominator is 0 when y is equal to negative 1/4. Pretty simple. So our vertical asymptote is negative 1/4. So we can put our range is equal to when, well, y, it just needs to be part of the real number set and not equal to 1/4, negative 1/4. And of course, the vertical asymptote is 1/2, and the horizontal asymptote is negative 1/4. So that was pretty simple. Okay, moving on to the final question. This is a very short section. And we need to do the same for y, what am I writing out? No, it's y is equal to 1 minus 2x divided by 1 plus 2x. So, domain, again, pretty simple. It's when x is part of the real number set, and, well, we need to find the asymptote. This denominator will equal 0 when x is equal to negative 1/2, so we need to simply say that x cannot be equal to negative 1/2. For the range, again, we need to rearrange this equation. So we have y times 1 plus 2x is equal to 1 minus 2x. So in this case, y plus 2xy is equal to 1 minus 2x. We want to bring all the x terms to one side, so 2xy plus 2x is equal to 1 minus y. And then we can factor the x out of this. So we can have x, or actually it might be simpler to just have 2x is equal to y plus 1. So 2x is equal to 1 minus y over y plus 1. And so we need to find values for when this denominator y plus 1 equals 0, and the only value is when y equals negative 1. So for the range of this function, we can simply have y is part of the real number set, and y is not equal to -1. That's the range. And so our horizontal asymptote is -1, and our vertical asymptote is -1/2. So that was all for the speed run, and I will see you in the next one, hopefully.